piecewise defined functions, part 3. Now, this looks like a system, but it's not. And the reason it's not is because technically there is no overlap. What happens in a piecewise function is there is a section where you're using one graph right here, but then after you leave this section of the graph, you use a new function or a new equation. So you use different equations at different parts of the graph. That's why they call it piecewise. It's like broken into pieces. So when you have a problem like this, you need to identify the pieces. So for example, right here, there's a piece that is at less than 0. So when you write your function for this side is when x is less than 0 or equal to. But over here, it's when it's greater than 0. Now, if you notice, I put a little line here and I didn't put a line here. The reason for that is this one, when it ended with a closed circle. When this one began, it had an open circle. So I left it open. Okay. So in your function, you're going to break it up into two pieces. You're going to have two functions where the first one is when x is less than or equal to 0, and the other one is when it's greater than 0. So now we need equations. We need to write down equations for each function. So to do that, just imagine it's a regular line. Just imagine it's a regular line going this way. Okay? What would be the equation of this line? Well, what's your starting point? It starts at 1. So use mx plus b. Use mx plus b as your layout. Okay, plus 1. Okay, what's your slope? What's your rise and your run? Well, it looks like it was going up 1 over 2, up 1 over 2. So 1/2. And there's your first function. There's your first function. Now, same thing here. Just treat this like a regular line. If this was the line you're working with, right? Now remember, this part doesn't exist. You're just worried about going forward. Where did it start? Well, that one started at -1. What was the slope of this line? Oh, 1, 2, 3 over 1. 3 over 1, so that's 3x. So I put 3x minus 1. And guys, that's basically how you write the piecewise function. Oh, now you're not going to have an equal sign here. Generally, the equal sign will be on this side. Your piecewise function, your f of x, equals these two together, but at different domains. And these are what they represent. This is one domain. This is another domain. When the domain is less than 0 and when the domain is greater than 0. And you have to write down that domain when you're using those functions. Okay? All right. Now, let's graph one. So here we have, again, a piecewise function that is made up of these two lines. Now, here's my little trick. What I like to do when I graph it. Now, it's better if you use pencil, okay? Wherever the split is, wherever you stop using one to another, I do like a dotted line. Just to separate it, just so I know that this is where one stops and the other one ends, okay? So one of the lines is going to stop here, and then afterwards it's going to start after that, okay? All right, so the first one starts at -3 down here. The slope is 2x, 2 over 1, up 2 over 1, up 2 over 1. And this is not an inequality, this is a line, so I just draw a line. Now, it ends with the 2 being x is greater than or less than, no, greater than or equal. So it's a solid line with a dot. It just ends right there. Now you can draw an arrow going this way. You can draw an arrow going this way because it goes on forever in this direction, but it stops right there. So don't put an arrow there, you put a dot. Sometimes it's closed, sometimes it's open. Because it has a line underneath it, this one's closed. Okay, the next one, +1. Now here's a problem. I'm not supposed to graph over here. I'm supposed to start over here. How do I do that? Just pretend for a second you're going to start over here. Okay, Just pretend. This would start at +1 over here. What kind of slope does it have? -1. This would be a -1. So it starts here, but it has a -1 over 1. So it would go down 1 over 1, down 1 over 1. Now this is where it's important. When you get to this is where you're actually going to start. I know this was the starting point, but you're not using this part of the graph. This part of the graph is only for this one. This line starts on this side. So it would have started here and would go down in this direction. So your first point is actually this point, but it still has the same slope, down 1 over 1, down 1 over 1, down 1 over 1. The line would still go this way. Okay? So I know it's kind of weird because you're kind of like drawing on this side to help you figure out where it should start on this line. Just do not connect the dots here. You can make your dots to figure out the pattern, but do not connect them because the line is already here on this side. You need the line for this side. And this one is open because there's no line underneath that. And this is what it would look like. Now, another thing I should tell you. The slope tells you when a line is increasing or decreasing, okay? Not the arrow, the slope. The arrow just tells you the way the line is going. The slope was the way this line was growing. This slope was going up 2 over 1. So this line is actually increasing. That's an increasing line. Up 2 over 1, up 2 over 1. It would have kept growing if it didn't stop there. This one is actually decreasing. The slope is going down 1 over 1, down 1 over 1, down 1 over 1. Didn't matter. It doesn't matter that it started on the positive side. It doesn't matter that it's on +2. The line is decreasing. Okay, and it has nothing to do with the arrow. It has to do with the slope. All right. One more. What if you have more than 2 lines? Well, then you want to identify every place where it changes. Okay, so I would recommend maybe using different colors just to identify, because you're going to need to use mx plus b. And when you have a line like this that's not connected to the y-intercept, it's going to be hard to do. So just imagine, okay, what if this line kept going? What would be the starting point? What would be the mx plus b of this line? 3. Now what's the slope of this line? 0. So this line has 0x plus 3. Well, if that's 0, guess what you're just going to use? 3. So that's the first one. 3. That's the equation. I know it's weird. Okay, when are you using it? You're using it at -2 for x. So remember, when x is less than, now, -2, going that way, you're staying at 3. Now, do I put a line underneath it? Well, look at the dot. Is it open or closed? It's closed. Put a line underneath it. So what you're telling me is from -2 and less than -2, every number less than -2, all this is doing is going this way. That's all it's doing. Okay, the next one. From -2 to where does it stop? At 0. This goes from -2 to 0. That is the domain. Sorry, let me write it differently. From -2 to 0. From -2 to 0, you're using a new function, which means you need to find the new equation to put here. So we need the equation for this. Again, you're using mx plus b. Where's your starting point? Where do we start? Looks like -2. Okay, what's the slope for this? If this kept going, right? If this kept going, what is the slope doing? It's not 1 over 1. Let's look at it. Down 2 over 1. Yeah, down 2 over, it's a -2 slope. So you have -2x minus 2. Your equation is -2x minus 2. That's the equation. But it stops right there. Now there's a gap. There's nothing here. So you don't need to write anything for here. the line picks up where? Where does the line pick up? At 1. So when x is greater than 1, now do you put a line underneath it? What kind of dot is it? Open or closed? It's closed. Put a line underneath it. When you get to 1 is greater, you're going to use a new function. Okay? So, again, you got to find an equation for this. The problem here is you don't go forward, you have to go backwards. Where would it start? Where would this line have started? +1. Would have started at a +1. What's my slope? Well, looks like it's going up 1 over 1. Yeah, up 1 over 1. So, I would write this equation. X plus 1. These are commas, sorry. These are supposed to be commas. So after you have your equations, right, you put a comma and you write down the domain when it's being used, okay? So you have your function first, the domain. The function, the domain, the function, the domain. Now, this has a negative slope, so this is a decreasing line. This is an increasing line. This one is not changing. It is staying constant, stays the same. But from -2, from here to here, it is decreasing. I'll put decrease. But from here to here, it's increasing. All right, and those are piecewise functions.